Our next presentation, it's Mr. Benjamin Piper. He's a senior architect from Atkins UAE Dubai office. Benjamin is a cross-disciplinary designer with 10 years of professional experience in architect and urban planning. As an architect, Ben has worked with a variety of global practices in designing residential, office, and commercial developments. He has developed a number of museums and visitor centers in the United Kingdom, a high-speed Eurorail terminal in Italy. Most recently, Ben has been involved in the design of a number of mixed-use towers, including a 60-story, 375-bed hotel in the Mumbai, and a 77,000 square meter LEED Platinum office tower in Bangalore. Please, Mr.
Okay, thank you very much. It's a 20 minutes, so we're going to move through quite quickly. In fact, the presentation is really to cover a project that's live, a live project. It's not a finished piece, but one of the the key questions being asked in the conference is why tall? And in fact, I'm going to show you a project that actually it started relatively tall, but it evolved into something actually quite low, but still with a very high population. And I thought I'd show a kind of alternative paradigm to the tall building. Do I need to click down here every time? Or okay, like that. So yes, this is a vertical campus for ITC. And ITC is a company, actually it's got a history in industrial production of tobacco, but recently they've been moving into information technology. And they have a campus where they have three driving forces behind their company and management attitude. It's people, planet, and place. And they had come to us to look at a way of redeveloping their campus to keep those principles in mind, but at the same time increasing the density to a great extent. So this is the site as it is today. And of course, there's an awesome responsibility when dealing with such an operating site with the flora and fauna. Many of the projects that we've been involved with before were in UAE, where of course we don't have trees of this kind of scale, and we don't have the existing operations. But one of the first things that we did was to analyze the organization in terms of its physical, the physical asset of the campus today. And what you find is that the company ITC, it has many disparate elements that are all arranged on this horizontal surface. And as a result, there's a very strong connectivity between the different departments. And they're brought together within this campus space. Now, the spaces in between the buildings themselves, while not strictly productive in the sense of being an office, they are still productive for the company. They are still of value, these interstitial spaces, and even more so the green spaces, the trees, and the landscaped areas that really provide these moments of relief from the office environment. And what that gives you at the end of the day is a highly connected organization. And at the end of the day, connectivity is probably one of the most valuable aspects of any group of individuals or intelligent system. And one of the risks of moving into the high-rise kind of scenario, this is actually a project from near the site, is what happens to that connectivity? You have the connectivity here on the ground, but what happens within the tower where the elevators really determine the connectivity between the floors? So we wanted to look at a project that was a socially organized tower rather than a sort of vertically transport organized tower, where those interstitial spaces would come into the volume, and the green spaces, the landscape and so forth would also be there in the tower, so that the idea of this horizontally connected campus would extend into the tower itself. And we really felt that such things encourages connectivity and productivity, ultimately is valuable to the company itself. So I'm going to just whip through here the kind of development of the form, starting with a very optimized shape, 24-meter depth to get the natural daylighting through the floor plate with the narrow dimensions between the east and the west to minimize the solar gain. But because we had some site constraints, we put this little staggered shape here. And as I'll explain later, we had some a streamlined geometry to help with wind resistance and further solar gain. So in the end, this was the kind of form, bearing in mind that we were trying to fit about 6,500 people in here, and we had a rather limited height constraint. And one of the challenges was how could we take such a large floor plate of about 3,000 square meters and make it look somehow elegant and break that massive shape. And I wanted to point out a few things here. I mean, we've got this opportunity for the sky gardens within the body of the building, some ideas about energy generation, which we investigated further, and there's some quite interesting conclusions about that. And also these sky gardens here, what we called social balconies, really as places for people to connect within the landscaped environment. So just moving through some of the plans, I don't want to go into too much detail here and really touch on the things that are quite unique to the project. One of those things was that it's quite common with such IT facilities to actually run the building at different shifts. And so when looking at the VT aspects in particular, we wanted to take that into account, that we could really optimize the vertical transport based on the shift patterns involved within the building. And it actually raises some quite interesting questions where in effect, the HR policy of the building, or the way that the building is operated, has a massive impact on the core requirements, for example. And now there has been a lot of discussion about to what extent do you design for a particular owner. In this case, it's quite rare. It's not a speculative office. It's an end-user office. But then with a 50-year time frame and thinking about sustainability, ultimately, the building should be highly flexible. So there is this issue of whether to optimize. If you optimize too far, you design something for too specific a set of circumstances, it may not last into the future. But you can see here, these were some VT studies to look at how we could reduce the cores. And in particular, we wanted to look at the possibility of not only shifting into 2 zones, which is quite common practice, but maybe looking at something like only serving every 3 floors, and then people would be required to walk up and down between the various floors, which again relates back to this idea of a vertical campus, where it's not just about getting from your car to your desk, it's actually the journey along the way, the people that you interact with, the kind of chance encounters and so forth. So we did some analysis of this, and in fact we found quite a significant improvement if people were prepared to actually walk some of the way. And again, we feel you can get the benefits both in terms of reduced cores, improved service time, and ultimately greater connectivity between people working within a high-rise kind of environment. And that has some quite interesting possibilities in terms of what we call, let's say, social nesting. Of course, everybody is working in this IT office has got their own desk, but then of course they have a working group, and then the floor itself, and maybe the floor above and below are nested social groups. And in this case, because we had split one floor on one side of the building, half a level from the other, every floor is only 1/2 staircase away. So ultimately, you are only 2 meters away from any other floor, which means that the building, rather than being considered as different floors, can start to be considered as zones. And then you get a stronger connectivity between this floor, and this floor. And similarly with the atrium spaces, where the elevators are arriving, where you might have pantries and more social type spaces, there is a kind of a community generation from that elevator arrival point. And because those themselves are also staggered, there's an interrelation between the atriums, and ultimately the central space creates a kind of a sense of the whole. So that's why I mentioned the idea of this nested social spaces, that you can both work within a relatively small working group, but at the same time have a sense of the larger organization. And such spaces have quite interesting possibilities for natural ventilation and nighttime cooling and so forth. So getting into that staircase itself at the center, this was forming the hub, the central hub of the building. And one point we wanted to make to the client here, because we had very strict requirements in terms of efficiency, the point was to say efficiency shouldn't only be measured in terms of productive space against non-productive space. Why can't we think about using non-productive space or circulation areas as being equally important for the production of the organization? So rather than trying to make them as small as possible, to expand the offices and so forth, to think of those spaces as equally valuable, and really even make them more generous, provide places for chance encounters and meetings and so forth. And in this case, we're actually using the Waverley stair, which has been designed to ergonomically allow people to move down with the same ease in which you move forward, and to do with the ergonomic design there. So just some kind of images of what that space might be. This is the triple height atriums with the grand staircase moving through, and plenty of opportunities for chance encounter. Now, I had mentioned the shape of the building itself and how that was related to the optimization, both in terms of solar and in wind. You'll notice that the prevailing wind is actually moving east-west depending on the season. And this aerofoil shape actually has the interesting property of accelerating the wind around the widest portions of the building. So we actually decided to move the turbines, which were originally here, to this location. Now, there was discussion as to the practicality of these turbines, and actually we felt that the client had always been stressing the passive aspects of the sustainability. Think passive before the active. I mean, cost was very much an issue. And what's quite interesting about this shape is that because it's asymmetrical aerofoil, you're getting a negative pressure over here and a positive pressure here, and getting natural ventilation coming right through that central atrium space. And by thinking of the building in two halves, as two environmentally sealed halves, people moving through that space are being constantly redirected towards the external landscape. I should mention that this is actually sited in Bangalore, which is one of the most temperate places in the world, and a fantastic opportunity to look at high-rise that is truly naturally ventilated, and to look at bringing those campus aspects into the building. I'd mentioned about the solar optimization. It's general practice that the shorter orientation of a building is towards the east and west, to take into account the low sun angles. But one benefit of the curved shape here is that by looking at particular coatings on the glass and the high angle of incidence of the sunlight against that glass, we could improve the solar performance even more as a result of the geometry. And we've been looking at various light shelf opportunities and exposed ceiling and so forth. But I think this is quite an interesting tool that we're starting to use in Atkins. We call it carbon curves. Essentially, it's a glorified Excel spreadsheet. And the value of this tool is that it's used very, very early in the design stage, even before a full energy model, which may take some time to turn around. This is based on historical data of all of our buildings and rules of thumb, let's say, where we can very quickly test the relationships between the geometry, decisions to do with massing and so forth, and the energy output of the building based on various inputs. And these are the kind of curves that we get, and we can start noticing so-called sweet spots where perhaps the depth of the floor in relation to the sizing of the AHUs or the specification of the glass, we're able to look at that from pre-concept stage rather than coming up with an overall design, detailing it up to some extent, and then only at that point finding out the internal relationships between the building fabric. Now, getting to that initial point, the question, why tall? Now, in this case, and I think in many cases, buildings are actually rather restricted in their height. It isn't the case that you can build super tall wherever you go, and that's certainly the dominant theme at the CTBUH. But here we had quite a specific height restrictions that came to light only after we had designed what I've just shown you. Not only that, but the client was interested in increasing the number of people. So we moved from a 25-story building with 6,500 to an 11-story building with 10,000 people, at which point we decided to break the building into two. But we still wanted to maintain these key thematics of bringing the landscape into the building and allowing people effectively to walk throughout. And while in a way we were disappointed to lose some of the elements of the tower, we were quite pleased because an 11-story building is much more feasible to make a truly pedestrian building with less loading on the VT. And at that point we also had this idea of what we called the social bridge, which is the canteen space that links the two slabs, and elevating that up into the air to limit the coverage and maintain the landscape underneath and really give people a view into the tree canopies and so forth. Actually, around this time, the movie Avatar came out, and it was quite inspirational, to think about society that lived inside the tree. And on this campus, there's trees with 40-meter canopies, and the idea of actually having the canteen suspended within that tree canopy was quite appealing. So at this stage, we looked at some broader master planning principles. I won't go into those in too much detail, but to say that it's always of great benefit to take the site informants, and they really add a lot of richness to any design. And we looked at everything from the wind and watersheds and transport access and views and acoustic relationships to the roadways, existing trees and other heritage structures. And in fact, the trees, again, coming from the UAE where I'm personally based, trees is something that we don't deal with very much. Working in Bangalore, trees are a significant element. I'd even go so far as to say that they're architectural elements, because these 40-meter canopies create these sort of cathedral-like spaces. And so we did an initial walk-around tree survey. We're in the process of getting a more detailed version of the same. And in the end, we came up with a master plan, which is very simple in its expression. But I was just actually chatting to the client earlier, describing this process a bit like a game of Twister. There were so many constraints that in order to deliver something relatively legible and concise and simple within those constraints was quite challenging. But this is where we are today in terms of the master plan. And one of the key driving principles is, as I had mentioned, to orient the buildings on the east-west axis, so we can minimize the solar gain, but we maximize the natural lighting across the relatively narrow floor plate. We've got this large social bridge, which contains the shared facilities, more or less, of the main phase one. And there's a hotel and some other offices. Now, what I'm going to show for the rest of the presentation is this phase one buildings, which are these two joined by the bridge. You can see here, this is the phase one joined by the bridge. The wind blowing through here, and the sun also moving in that orientation, so we can get plenty of landscape between the buildings. Now, this raises a kind of interesting point to me. There's often seems to be a reoccurring dichotomy between the urban requirements and architectural requirements. So if you take sunlight, for example, if you want to optimize sunlight for the building in terms of solar gain, it's ideal to put the short ends of the building towards the east and the west. But of course, if you want to shade public spaces and the outside, it's actually ideal to put things in the other way. So I think there can never be any simple hard and fast rules. I mean, each site needs to be assessed. And I know, for example, in China, I mean, the practice of the south-facing residential units, I mean, this is a certain kind of attitude which may or may not be relevant to particular sites. But in that case, that was the choice. So to give some sense of the so-called game of Twister that we were playing, this is the site as it is today. We're going to be putting in a data center, demolishing the buildings in red, taking out some trees, but keeping trees where we can, and then building up the phase one there, then demolishing the next area, building up the phase two, demolishing and building up the phase three, and then demolishing and building up the phase four. And that's all at the same time trying to keep that operation running and increase the density from a current 3,000 people on the site to 20,000 people on the site, with the phase one being 10,000 in these two buildings here. So to get onto the phase one, there was a very strong idea from the very outset, the idea that you could walk within the building as if you were walking on a campus. And because of the extreme demands on efficiency and simplicity, we decided to go for an absolutely simple form with this one kind of element of the landscape moving up the building. So here we have these terraced gardens, and they allow you effectively to walk from the ground up to the canteen level, or from upper levels down to the canteen. And so we're hoping that perhaps a one-third or less impact on the VT. I mean, bearing in mind that on certain days it may rain and so forth, one can't necessarily design it for that alone. But one of the things I think is worth mentioning here is that local constraints, local planning law, it always makes an enormous impact on the actual outcome of the architecture. In this particular case, what's happening in India today, because of people taking advantage of rules and regulations thus far, there's actually a very draconian attitude to FAR, which of course is what the client is keen to get exactly spot on. So we had the constraint of not being able to have any of these balconies under a concrete cover, or the drip line as it's called. And that's one of the advantages of this terraced approach. All of this is effectively free of FAR, which means it's free of parking, but at the same time it is usable space. And this is why I get back to my original point that these circulation areas, while you might not be able to put desks there per se, they are still extremely useful. And if you take this conference hall, for example, while the auditorium space is the productive space, it's also the space outside the circulation areas where real conversations are happening, real business is taking place, chance encounters, and those are things that really still warrant bringing people physically together in buildings. You might ask, why don't we just invest in the IT aspect and people can work from home? But at the end of the day, that physical proximity and that sense of community is extremely important. So sections through the bridge here, and cutting through there. And this is some initial renders of that bridge space. One of the aims was, because it is actually perpendicular to the flow of the wind, we wanted to make this a naturally ventilated space, which is quite a significant volume in the building, and again, bringing the energy levels down further. And it has some openable windows, depending on the wind speeds and so forth, that we can open and close those. So this is some sense of what that space might look like. And bearing in mind that the client is actually coming from quite an industrial background, and we wanted to keep some of that heritage and qualities alive in the space, a very simple, robust space to last for many years to come and be highly flexible. So we're currently in the process of looking at some different options for the facade. Here we're interested in the possibility of a dynamic facade on the west there. Again, bearing in mind some cost constraints and so forth, but we're looking at that now, perhaps with some counterweighted systems. We're trying to weigh up the pros and cons of fully automated with manual control and so forth. And this is a further iteration of that under development. And this is the gardens moving up, some reflection pools. Again, to fit the numbers in, we really had to bring the space down in between the buildings, but we've done some solar studies to ensure that there's always, even during the lowest sun angles, there's always sun landing at the lowest levels of the building there. And these are some of the Jolly screens, which are a local typology in India that we're looking to employ there. Now, on that point of flexibility, the most sustainable thing that you can do as an architect is to build a building that just never gets knocked down. I mean, a building that is never becomes redundant or unuseful to the new shape and form of society. So there's a kind of a dichotomy between optimization and flexibility. And we're still in that conversation. But with the industrial background that the client has, they very much see many of these processes as almost like an industrial process, supply chain. But one must be careful if tuning the development too closely to a particular supply chain. When that changes, the development could become redundant. So we're continuing to emphasize flexibility, simplicity, loose fit, long life. I mean, these are things that people have been saying since the 60s, but I think just as relevant today. So you can see in these very simple floor plates the opportunity to divide and subdivide. And then looking at the natural ventilation aspects, you can see here some ideas about simple openable windows, looking at the interrelation of the masses. And the conclusion that we came to from here, quite interesting, was that rather than thinking about winds actually being brought into the building, that if we can create negative pressures on the outside of the building and then draw breezes in, we can get a much more even distribution across that. And we're currently weighing up the sort of forced ventilation versus completely natural pressures. Again, on this topic of optimization, this was just a little study that we had done looking at a 9-meter grid and a 12-meter grid in relation to the furniture. Now, as an architect, I'd always understood that the broader the grid, the more flexible the space. But this was quite interesting study because what we did is we actually laid out desks at the bare legal minimum. And because the desks here are in a... By the way, I should point out, this is not a proposal, not a proposed furniture layout, it's just an analysis. But because the desks are 3 meters when you put two together plus a 1 meter aisle, basically it's a 4 meter module, and it works much better with the 12 meters in this direction than the 9 meters. But then when you look at the parking, it's also working relatively well. So those kind of optimizations have been very much part of this process. So just to finish up before I get the final bell, one thing we'd certainly emphasize, I think some speakers said this earlier today about Hong Kong, definitely emphasize the high density, and that's, once a building is built, if it can be used very well and fully, this is an ideal scenario. In this particular building, we've really tried to maximize pedestrian movement, even in a semi-high-rise, let's call it. And I think it's a challenge in high-rise buildings to look at how we can have slightly different attitudes to vertical transport that doesn't necessarily involve getting into an elevator. Elevators, after all, are terribly sterile spaces and are socially extremely awkward because you're sharing this short trip with the people in a very confined space. And perhaps we should look at staircase links that encourage connectivity, are more healthy and perhaps even cheaper and more efficient. So the point, long life, loose fit, low energy, I think it can be restated again. Working within the local constraints, again, in this particular building, much of its character has come from some of the slightly arbitrary planning regulations, but I think rather than being simply frustrated by some of those, that we can celebrate those and turn those into architecture. And ultimately, affordable and repeatable architecture is what we should be aiming for, because if there are these few rare moments and jewels of sustainability that are so expensive that they can't be repeated, or so technologically advanced that they can't be taken up by en masse, let's say, then we're not really changing the world. And I think one of the values of this project, and really to thank the client for that, is that we've really tried to emphasize simplicity, minimal cost, and ultimately repeatability, affordability. And those tie into some of the themes of the conference: green, safety, and humanity. With that, thank you very much. I'd love to talk to you later if you have any questions.
Thank you so much, Ben. It was really interesting topic. I personally enjoyed. If anybody has a question, please, welcome. No question. Okay. I have a question just for my own interest, because the sustainability is the hot topic these days. Everybody's talking about that, and you were talking about the carbon emission and zero efficiency for your project, and based on your company practice, and getting data from the other projects and come with the graph. Did you consider based on the different zone and temperature for other countries? This is, just I'm interested to know. For example, if you are in Russia, the temperature is so cold. Yeah. Or where you are in Dubai, that also is considered to your graph, or?
Well, to some extent, and actually, we don't have so much experience as a company in India in particular. I think one of the interesting aspects there is that it does make a difference where your design team is sitting, because at the end of the day, we're always making judgments, personal judgments. And even in Dubai, where I'm from, when it's the summer, people are always emphasizing the air conditioning and how the building has to be perfectly sealed. And in the winter, everybody's talking about pedestrian movement and should be openable windows. So even the same designers in the same place will change their attitude to the design depending on the external conditions. And really, it's one of those quite subtle psychological things that just tends to happen. And I think whenever we visit the site, we're always being taken by our client for lunch outside to remind us it doesn't need to be air conditioned, and to address local conditions. And I think in this globalized world in which we live today, we're all designing things all over the world, and that connectivity that one gets by spending a lot of time in a place is a very difficult thing to replace. And it's probably, while we're advancing in many ways technologically, we're probably devolving when it comes to the sensitivities and sort of local custom and sort of age-old vernacular experience. And I think that's probably a good thing that we could bring back into architecture, if at all possible.
Okay. Thank you.
Thank you.
Mr. Piper, I have another question for that. Okay. Your social connectivity is kind of very interesting. So my question is for security. So is there any special or specific considerations on security issues for that?
Yeah, no, it's an excellent question. And in fact, I think it's one of the big challenges on this is to look at security. And I was watching with some interest one of the previous speakers with this very sophisticated access control. I think, in fact, what we're doing now is carrying on with the design with the access via the terraced gardens as an option. It's not fixed 100%. As a very base case option, we're considering that it's at least a fire escape, because while it can't officially count as a fire escape because it's not 2-hour fire protected as such, in reality, when you have 10,000 people, and if you are responsible, one should be able to use such a simple way to get down to the ground. So as a default position, we're considering it as such. But I think we'd need to look in more detail, and I'm going to be speaking to the gentleman about his system and see how we could apply it here, because it would allow certain floors to be open at certain times and be an adaptable approach. If a secure floor wants to be closed, they can, but if it's a more open floor, then that could also work.
Okay, thank you.
Okay, thank you.
Thank you so much. Okay.